Welcome back to my channel. Today we're diving into one of the most common questions in data analysis. When should I use a parametric test? And when should I switch to a non-parametric alternative? Let's break it down simple and clear way. In data analysis, we often use parametric tests when certain assumptions are met, like normality, equal variances, and linearity. But when those assumptions are violated, non-parametric tests come in. Let's look at some popular parametric tests, their key assumptions, and what to use when those assumptions don't hold. 1. Independent t-test versus Mann-Whitney u-test. Use an independent t-test when you're comparing means between two independent groups, but only if the data is normally distributed and variances are equal. If your data isn't normal or variances are unequal, switch to the Mann-Whitney u-test 2. Paired t-test versus Wilcoxon signed rank test. For related or paired samples, the paired t-test assumes the differences between pairs are normally distributed. If not, go for the Wilcoxon signed rank test. 3. Simple linear regression versus rank-based or quanto regression. Simple linear regression assumes linearity, constant variance, and normal residuals. For violations like outliers or non-normal errors, try rank-based or quanto regression. 4. Multiple linear regression versus ridge lasso regression. For more than one predictor, multiple linear regression has the same assumptions, and you also need to avoid multicollinearity. When assumptions break down or predictors are too many, go for ridge, lasso, or non-parametric regression. 5. One sample t-test versus Wilcoxon signed rank test. Testing a sample mean against a known value. Use a one-sample t-test if the distribution is normal. If not, switch to the Wilcoxon signed rank test. 6. Logistic regression versus classification trees. Random forests logistic regression is great for binary outcomes, but it needs a linear relationship in the logit. If that's not true or your predictors are high-dimensional, go for classification trees or random forests. 7. Discriminant function analysis versus k-nearest neighbor. For classifying cases, discriminant function analysis assumes multivariate normality and equal covariances. If those assumptions are violated, use k-nearest neighbor or decision trees. 8. Z-test versus binomial or sign test. Z-tests work when variances are known and samples are large. But for small samples or unknown variances, go with the binomial test or sign test. 9. Chi-square test versus Fisher's exact test. Chi-square tests require large sample sizes and expected frequencies above 5. For small samples or low expected counts, Fisher's exact test is the better choice. Knowing when to use non-parametric alternatives helps you avoid wrong conclusions in your analysis. Bookmark this video as your go-to guide for choosing the right test. Like, comment, and subscribe for more data tutorials.